There you go. Now you can hear me. My mic was off. What's up, people? What's up, everybody? It's streaming time. It's Friday. You may have noticed a new beat for the stream starting soon video because somebody took the beat and made the song out of it. So I've gotten copyright strikes on my past like 3 streams. So it is what it is. But we're back to work, and yeah, actually, I'll show you guys my screen. There you go. And so what are we doing today? Actually, I can pull out the website super quickly. My raspy voice. I need to get some water. Cool. So if you actually go to articles, I had just released the Caesar Cipher Codex article. So this article is literally the entire structure and implementation for the Caesar Cipher within the Codex project. So this was the first 3 streams, right? This basically, I guess, includes the first cyberlog where we implemented the Caesar Cipher, but it literally teaches you everything that I'm kind of my understanding of all this stuff and kind of how I implemented it into the code. It covers how the Caesar Cipher works, the algorithms behind it, how to implement it in Python for encryption, the brute forcing process, implementation, and of course it links to the code, which is on GitHub. I will go ahead and actually copy this link and drop this into here. I probably should pin it at the top so that way you guys can go ahead and check out the code if you guys want to check out the code. This project is, of course, incomplete because we're still working on it. We're streaming every Friday to work on it. But yeah, I guess that's my super long-winded update. Still find that funny. Oh yeah, the song. Yeah. Sweet, sweet, sweet. All right. So last stream, we finished implementing the Visionaire cipher. So I'm wondering, like, I guess it's like about time we start implementing the new cipher, right? I guess we should do like some, basic like checks and debugging and stuff to make sure that the code is, still, I guess, working and that I didn't mess anything up. And the stream quality is really good. Because last stream, it was like bugging out and stuff, but right now it's looking really good, so let's hope it stays this way. I'm just chilling right now before I have to jump into a whole new cipher implementation. So I guess we go on the roadmap and see the other ciphers we should start working on. We finished Caesar, and we got Visionaire in here. I guess we can kind of copy like a little bit more of an easy one. Because if we go on, it's going to automatically play one of my videos. So I'm gonna just fucking freaking. We're making it up in the world. Claiming free music is almost as funny as using a Purge mask as your brand. That's funny. That's funny. A bit of an inside joke there. So, where is it? Let's look at the playlist. And if we go on the Codex project, view the full playlist. Okay, so right now, this was all. What is this? This was the Caesar cipher. Then this was the update for these 3. Then we have these 3, which was the Visionaire, and we just finished those. So right now we have to start a new cipher, and I'm figuring out which one would be the best one to start off with. right? I think I'm gonna tackle all the numerical systems at once because I feel like that would just be easier. So I'm gonna ignore those. I think I could do like base 64 maybe. I don't think I actually have a write-up for that. No, I don't. I could do reverse. Reverse is going to be super easy because Python already has a reverse method, right? So you could just... If you know, you know. Most definitely. All right, so I think I might tackle reverse. I think it's just going to be an easy one. We can kind of just get out the way, and then we can deep dive into base 64. So reverse cipher should be pretty simple. So it basically just reverses the text, right? I know, like, if you take it as a string and do like string indexing to reverse the string, right? It's like colon colon -1 to reverse it. Or you can do a dot reverse method, but I don't know if the dot reverse method is specific to like data structures like lists or if it's also specific to strings. But I'm too lazy to Google it, so we will kind of just struggle and figure that out. You know, that's how we roll here. So let's go ahead and actually open up VS Code. Cool, sweet. So yeah, we finished Visionaire Cipher. I guess we should do a little bit of testing, making sure that this thing didn't just die on us. Will the reverse still keep the spaces? I would like to make sure it does, yeah. I don't want the ciphers to reformat the plain text because that would be kind of bad if you're doing like a CTF or something. Sweet. Yeah, what were we doing? CD into documents, code, Python, and our codex. So we can Python 3 our main.py, and I can make this a full screener. All right, yeah, so we got that Visionaire. So we were able to implement the tech U, right, the unknown key. So for the unknown key, do we have any like, oh yeah, the unknown key, we need like a file for it. And I think I deleted all the files. You know what? We tested it last video. We're not going to test it this video. Y'all can just check out the previous stream, scroll through the 2 hours of footage, and hopefully find it. All right, so let's start the new one. Let's do our reverse cipher.py. Awesome. So I'm going to keep the Visionaire up here. No, the Visionaire is long. That's the longest cipher, the longest like code space for cipher. I think it's like, yeah, I'm just going to have Caesar cipher. So we're just going to use this. Actually, hold on. Let me think this out. We're going to use the Caesar cipher as a reference. I will test it really fast. Cool. I mean, if you want to, yeah. Code's up there. All right, what are we doing? What are we doing? So, to get started, all right, yeah, we're just gonna delete these comments. We will, oh, do we have to like, I'll leave those there. What the heck? Copy the little shebang then. And so instead of Caesar cipher, this is the reverse cipher package. And then we're gonna need these. All right, so let's go ahead and get our banner in here. So we can just say banner, and then we're going to say banner is equal to a doc string. All right, and then basically we're just going to need to make a banner for this whole thing. Let's whip out. All right, So we're not using too many web browsers. I'm gonna just close this because that's for business stuff. This is for programming stuff. Sweet. All right, open a new one, and what are we going to do again? Oh, banner, right. I think I never took this out of here. Yeah, I need to put this somewhere else. All right, so instead of the owl, we're going to do reverse cipher. All right, that looks kind of sweet. Copy, paste. All right, and then we're going to have to Control H, take all the backslashes and replace it with a double backslash. All right. So in our PowerShell, we'll have to CD into our ciphers, clear, and then list what's in here. Oh yeah, so this is where we'll have to test the actual cipher. So in the main.py, we're going to need to okay, so if ciphering option is text C, if this is text V. All right, cool. So in here we can do elif ciphering. Oh, Kite's back. Oh my gosh. It was gone for a little bit. I was concerned. Elif ciphering option is equal to. So I guess tech R should be for reverse. So we can do os dot system, then our f string of Python 3 dot slash ciphers, and then our reverse cipher dot py, and then our string args. Oh, that's awesome. So I guess we should start notating these to make it a little bit easier. We can say Caesar all right, and this is our visionaire. Visionaire. Oh no, I'm spelling this wrong. I always forget how to spell visionaire because it's such a weird spelling. All right, and then this is our reverse. And then I guess this is like the quote-unquote exception, right? All right, awesome. So we got all this fancy stuff in here. So if we were to use the, so I guess we can use the main actually. So we can see the end here. If we do a Python 3 main.py and then do a tag R in here, if we just, I don't know, print banner. If we run this, oh, let's go. Look at that implementation. Look how quick that was. We already got the reverse cipher imported to our main.py. So now we can just throw the parser in here and then throw the CLI in here and then just do implementation. Look how easy that is. So in our Caesar cipher, we're going to need a help menu. All right, yeah, so we'll have to start planning out the help menu. So we can just say help menu for ciphering process. We can do help underscore menu. It still works? All right, sweet, sweet, sweet. A friend of mine pointed out how much I say sweet. And since I did that, like since they pointed it out, it's like kind of blowing me. All right, and we can worry about this later because that's not our problem right now. I guess we should throw in the parser and then the command line interface. And we'll have to literally mod. Oh my gosh. All right, yeah. All right, I'm literally just gonna have to copy this whole thing. All right, cool. Really, just the bottom half of the code. All right, now it's time to modify it. So instead of Caesar parser, it's going to be reverse parser. So with the reverse, we don't need a key. So we can get rid of this. So with our ciphering options, are we doing attack F for file or attack I? Attack I. Attack I. Interesting. So this needs to be an I. Save myself some trouble in the future. And then T for text. And then O will be our output file. And then what's this R thing? Oh, the range for the brute forcing. And then, yeah, so that's good. Input file, text, output file, and range. Oh, well, we don't need the range. Like I literally just said that. So I need to start paying more attention. I'm sorry, guys. And then our argument dictionary. So we got rid of the key. We got rid of the key and the range, so we don't need either of these. We only need the tech I, the tech T, and the tech O, which is good. All right, now the command line interface. It'll print out the banner. It'll check our arguments, and instead of the Caesar parser, it'll be the reverse parser. And then, all right, it'll do this thing. Continues with received argument, so key equals, well, we don't need, so print to content will equal true. Inputted content, we'll get the tag T, so we can get rid of this because we'll still have our tag T, right? Yeah, we still have our tag T, awesome. So we'll only need the tag T, print content equals true, if the I is in there, if the O is in there. And then we don't need a range because we don't have one of those. Ciphering process will be from argument point 1. Okay, is that right? Because 0 is... Or didn't we have to make this 2? Well, we're only going to have an encrypt and decrypt, so we can get rid of the brute forcing option. Okay, if it says 1 and it's working, then I would just trust it, but I feel, part of me feels as if that's not right. Oh no, it's because we're running the file in the main.py. So we're not actually, I guess, importing it into the project. We're using the OS. That's right, I forgot. How smart of me. If you have any ideas for projects you would like to see, please join the Discord. Stuff. Yeah, actually, join the Discord. Links in the description as always. It's actually kind of hype over there. I can't even lie. So we have this encrypt Caesar and decrypt Caesar. So we're going to have an encrypt reverse. I don't think I spelled encrypt. Oh no, that's right. All right. And then we're going to have our decrypt reverse. Then we'll have the inputted content, the key, and the print content. Sweet. So I guess it's time to actually start working on our actual process to encrypt. Thank you for putting that in the chat. So, time to start encrypting. I guess I don't really need to explain how the reverse cipher works, so let's quickly say it. It takes plain text, normal, and then it reverses it. There you go. You guys are all caught up. All right. So we're going to have our encrypt reverse. So this will be def encrypt reverse. All right. So in here, what do we need again? It's the input of content, something and something. Encrypt reverse. So input of content key. Well, we don't need a key because, there's no key for the reverse. Thank you for that. I was so lost. Oh, no problem, man. I'm glad I could catch you up to speed. But we both know there's like the one viewer who didn't know what I was talking about. So, how am I going to do this? All right. So with the encrypt, what's the parameters we use? Because I'm trying to stay consistent with my code, which is rare. I know it's very rare. Plain key and then, or plain content, print content. All right. Plain content, print content. Sweet. All right. So it's time to whip out this thing. Let's see if we can just Python 3. So we'll make a string. We'll say hello world. So do strings have the dot reverse or is that for lists? Okay, well maybe you should spell reverse correctly. String object has no attribute reverse. All right, so we can just do s, then the : -1. And yeah, there you go. Sweet. That's easy. So we're just this is such like a beautified version of the the : -1. All right. I think I might like do all the easy ones in this stream, so we can just save some time up. Because basic 4 should be pretty easy too, right? Because Python already has a module for that. I don't have to code any, I guess, algorithmic stuff for it. All right. Sweet. All right, so we're going to take our plain content. So I guess we can just say output is equal to the plain content and then : -1. And then we'll just have to use whatever thing we have for the outputting stuff. So we can just get this, copy, and paste. So output equals plain, and then we got the : -1. Then we say output the content, so if the content is true, it'll say the encrypted content. Oh, you know what we could do? Because if you reverse it, right? Okay, so we'll just say n for new. So if n is equal to s, and then there's : -1, right? So n is equal to the reverse version. If we just do n : -1, it just reverses it. So we'll just have this. So if they do attack R, then have the tag T as their text, they'll just reverse it. So we'll just say reversed content. And then we'll just say output written to file successfully. All right, that's awesome. That's easy. That's a lot less work because there's only one way the cipher works. All right, awesome. And then, sorry, I need to turn. Motzi pledged $10. Thank you, Motzi. Look at you getting all that exclusive content. Sweet. I'll have to add you to the outro. Reverse. I think like a lot of my old content's on there. All right, what are we doing now? Well, if we don't need attack E or attack D, because you're not encrypting her. I mean, I can if I want to, but at the end of the day, honestly, we can just make the argument. Well, if it's already tech R, it will just automatically just take whatever input and reverse it. So, where do we do this? So, after this, we'll check to see if it's this, we'll reverse. So instead of checking, we just reverse the content. Am I right? I don't know who that Monty nerd is, but he does sound cool. Yeah, he really does. He really does. I was going to say something meaner, but I realized I was streaming, so. All right, guys, let's get back. So we have almost everything done. The only thing is, well, the ciphering process, we're not going to have one because there is no ciphering process. You're just reversing the string. So this should be it, right? All right, let's hold up. Let's like Control Z exit. There you go. So if we Python 3 our main.py, then do attack R, and then attack T, hello. Interesting. Okay, what's going on here? So argument equals reverse parser. No value was given to your argument. Is that the error? What error did we get? No key or argument key, whatever, blah blah blah. So we try to reverse the inputted content and print content. So our inputted content is equal arguments.getT. And then it's because it's checking yeah, it's checking from index 2. We need to check from index 1. So let's try this. There you go. So we put in the text hello and it gets all that, right? So can we echo hello world to a file? We'll just call it file.txt. All right, so if we do attack I for the file, which will be file.txt, what? What's this? Do you guys, what? Why did it do that? Is that in the file? Is it because there's a new line? Do we have to like strip it? And there's like weird spaces. So it works with text. It's having trouble with the files. It might be where we're reading it. That is Old Norse. Did the like Norse people just like use reverse ciphers to communicate? It's like the Caesar cipher of like Norse mythology. Where on earth did we set up the tech I? So the tech I in arguments, we get our inputted content. So we're basically resetting this variable that gets the text input, and we're getting arguments that open, and we're getting that tech I in read mode, and we're reading it. So we do like a inputted content dot strip. So we have one other option here, right? If we can't do this, instead of like using string indexing, we could probably do like looping and then just reversing it that way. So that way, no matter if it's a file or if it's text, it will reverse it, but it's more work, you know what I mean? So like, I'm still considering it. Okay. I mean, we could just like remove the spaces or something, but. All right, let's print. Ooh. So print the inputted content before we just. Yeah. Should we just do like a dot remove and then. Okay, but why are these spaces here? Why is this at the beginning of our file? So when we open our file.txt, is this like a common error? I'm genuinely curious. So when we read our file.txt right here, we're just getting Old Norse, apparently. Print inputted content. Okay. I guess we could do some inline formatting here. So maybe we could do like what if we change our file? So is that like hello world, or can we do like subscribe to Cosmodium CS? And then I just want to see if there's like different Norse characters depending on the file. Okay, so it seems like there's going to be the weird characters, and then it's going to add as like a space in between each character. You know what we could try doing? Inputted content will equal inputted. This is such lousy coding. Like, don't do what I'm about to do. From index position 1 down in areas of 2. Is that right? Or is that right? Hold up. No. Down to the end of the file. From index position 1 to the end in skips of 2. Maybe it's like 2 too. This might not work. I could just be doing. Oh, there you go. That's kind of some lousy Should I do like an if starts with? Held together by hope, dreams, and duct tape. That's literally like my life, man. So if inputted content dot starts and then can we just do that like no, because if a sentence genuinely starts with this on the off chance. All right, yeah, so that's fine. Okay, so I guess that works. I'm curious, however, that if we were to encounter a I don't know. I guess it works, so I should just let it be. Can we do an output file? Can we, so if we run this, yeah, it says reverse content, and then it says Scamadiasoc Ots Ebricus Bus. Yeah, there you go. And can we have this be outputted to a file? Can we just do a dot, so attack go to out.txt. Output was written to file successfully. So if we check out our out.txt, all right, so it doesn't do the out. Does it not reverse it again? Or like, why is our out.txt still reversed? Oh, because that's what we're, oh my gosh, I'm dumb. I'm dumb. Ignore me. Ignore me. Ignore me. It's working. I was just tripping. It's working. So if I put a, all right. So let's put this. So our out.txt should be subscribed to Cosmodium if I run this. So if I go to our out.txt, subscribes to Cosmodium CS. Awesome. So it works. So we finished it. We're going to delete the file.txt. Out.txt we can delete. I don't know why it's taking so long to delete them, but it's alright. We can close the roadmap because we don't need that. And once it finishes trifling, then I will push it up to the GitHub because we got that one done. Wow, it's taking its sweet time. Okay, there you go. That's good. There you go. So we got... Oh, no, wait. We're not done. We're not done. We forgot something, people. For those who don't understand how to turn a string around, we got to do the reverse cipher help menu, right? Well, we're basically just going to do a good old copy here and paste. Sweet. So we'll do reverse cipher. The first argument is going to be nothing. There's no first argument. So an example is our main.py. Why is this? Main.py. Then the tech C for Caesar cipher, tech E to encrypt, tech K for okay, cool. So for this one, we don't have a tech C. We don't have a tech E, you don't have a tech. So yeah, just tech T. So yeah, that's a perfect example. We don't need either of these things. And then, yeah, so tech T, a tech I, and the tech O. And we got the help menu, so we can just copy this, go to our main.py. drop this in here. All right, and then we can just tab that over. So then now we can just do, oh, wait, that's the wrong one. No, it isn't. So we can do attack R equals reverse. Caesar cipher. This should be the Visionaire cipher. And then finally, whoops, cipher. Interesting. Why is this not working? Found not found. Oh, it's because we deleted it. Oh, okay. Oh, we should probably incorporate that. Oh my gosh. Well, gonna have to be like, hey, if this file doesn't exist, make sure the file exists. Oh my gosh. I almost choked on my water. But I literally just finished the past 3 ones, and I'm about to push this up to the GitHub. Well, now you guys are going to have to wait, because I know there's going to be the people who don't know how to list a file. Okay, stuff. Alright, so let's open up the Visionaire cipher, reverse cipher, and Caesar cipher. Sweet. We'll start from the Caesar cipher. We're basically just going to try this, and then if we get that error, then whatever. So right here. So if it equals this, we're going to try. Then input it on, and then we'll say accept, and then what's called file not found error. It's right there. Then we can just say print the attached file does not exist. I'm going to do the documentation. Tries to read file, and then we're going to have to be like file does not exist. Sweet. When we are just going to copy this right here. Actually, we should probably just copy this. Sweet. Alright, so Visionaire. Let's go down to wherever we check. This file is so big. You guys can see how long this file is. 362 lines of code. Sweet. Alright, so we can go here. So does this do the exact same thing right here? It does? Awesome. So we can just delete this line. Perfect. So far the reverse one is the shortest one, which is pretty cool. We're going to go under here, throw this right here, and then we'll say, we'll literally just copy this and throw this in here. We'll have to tab it and then hit enter, and all right, there you go. So now if we were to run this, it would say, whoops. Oh, now the file.txt exists. Hold up. Delete this file.txt. There you go. So if we were to do the tech I, the attached file does not exist. Awesome. So we'll have to do that little thingy. Alright, so once I finish doing this and all of those, I will push this up to the GitHub. And we're done streaming. No, it's only been like 40 minutes, so we'll keep going. But alright, cool. Let's push this up to the GitHub. So implemented, nah, that's too long. Added reverse cipher. What is it? Control Enter. All right, and then we can sync it. And there you go. It should be up there. So if we go, we can close this. If we go on the Codex project, we may need to refresh. Added reverse cipher. There you go. Look at that. So ciphers, right there is the reverse cipher with all of its beauty and stuff. Sweet. So reverse cipher's done. I guess we can kind of just tackle the next one because that was really easy. Ciphers. Oh no, we need to go on roadmap. So we finished Caesar. I'm doing all the number systems at the same time, so I'm gonna save that for like a stream. We can do multiplicative. I'm trying to get all the basic ones done now. Then we'll move into XOR, and then like the numbers, and then hashing. That's kind of like the stages right now. So like all the basic ciphers. And then I also want to incorporate like AES in here, some more complex stuff as we start moving forward. But I'm figuring let's start off easy because I'm lazy. You know, as I say, save all your problems for like your future self. Just let like tomorrow me, like, or next week me on Friday have to worry about these problems. Like with Rot 13, I could probably just do like an automation for like a shortcut just for people to get Rot 13 so that way they don't have to do. Nah, I'm lazy. Caesar cipher and Rot 13 are the same thing. It's just Caesar cipher with a key of 13. Y'all can do that by yourself. I might do it. What do we think? Let me know. That is how he runs his company too. No, I don't save my problems for my future self. I save my problems for you. All right, so I guess multiplicative would be the best one. All right, load. Shell script for the multiplicative cipher. All right, when it had to encrypt, decrypt, brute force. So use multiplication to create a ciphertext. So this is the indexing, right? We got our alphabet here and our numbers here. And then, or our indexes, alphabet indexes. So to encrypt, we have our index multiplied by our key, modulus 26. So decrypt, I'm assuming is iterate through each key to find the new index. Interesting. I know that the labor laws don't like it being said. That's funny. Sweet. All right, so we need to let's check out our cryptography resource for Python. See if they have anything for the multiplicative. Perfect. Look at that. So yeah, they have alphabet in their indexing. So the key is a numerical key, right? It's for excuse me. Advantages with multiplicative ciphers is that they work with very large keys, like 8 million, whatever. It would take quite a long time for a computer to brute force the majority of 9 million keys. The numbers will be used for multiplication procedure and associated with the key is 7. Okay. So yeah, numeric key, sweet. So with brute forcing it, I guess we had to specify a range, right? Because we're not just gonna brute force a solid like, hold up, my phone's about to die. Oh, Sister just got here. What's good? Oh, he's gonna be right back. Never mind. Let me get my phone charger. All right, I'm back, boys. And I say boys because I saw my YouTube analytics and it said 100% of y'all are boys. Your thing gone. Oh, no, you're good, man. You're good. So, basic modulation function for multiplicative cipher. Okay, so when you're reversing the cipher, like when you're decrypting, you're just dividing, I'm assuming, right? All right, it's time to whip out Python 3 again, do some configurations. So our little equation thing is what? It's going to be index multiplied by the key. Hold up. All right, there you go. So index multiplied by the key, and then it's going to be modulus 26. Yeah, sweet. So if we have I, so our index, let's say we're using the letter E, which is 4. And then our key, we'll say our key is like 7. So we'll say def, and then we'll say M for multiplicative cipher. Then we can just take in our index and our key. Then we can just do our index multiplied by our key. There you go. So index multiplied by the key. Then we can do our modulus 26. That looks about right. So if we do M and then we do an IK, I never printed it out. Whoops. Prints M IK. I should have returned it, but it's too late. None. Oh yeah, I never returned it. I'm dumb. This is why I don't code in like modules, or consoles. All right, so we can just return. Oh my gosh, guys, I'm so dumb. This is don't do basic programming in modules. Return. All right, there you go. So if we go back up here and print this, it says 2. Okay. So our encrypted with a key of 7. Is that right? Okay, that's cool. So wait, what did they do? If they had the letter E and they encrypted it with a key of 7, it had the index of 2, which is C. Okay, so that works. That works. So how are we going to... So how do we reverse this, right? So I guess we'll just say D, def D. Then we can take our index and our key. Then we can return our index divided by our key, I'm assuming. And then modulus 26. I'm assuming that's how you would do it. So if we did okay, it says 0.5. Yeah. So how do you reverse decrypt a multiplicative? Well, good thing there's something called Google. You know, just decrypting. I'm gonna at least try, making it by myself for a little bit. Decrypting multiplicative cipher. Is this the website I was just on? Yeah. This is literally the website I'm actively on. They don't completely cover decrypting with it. Let me see. Cryptography tutorial. Oh my gosh. No comment. You could tell they programmed this in HTML. Like they made this by themselves. Like this is like, I'm curious, like if I view the source. I admit the code seems pretty cool, but the colors throw me off a little bit. All right, so in general, PA. Okay, so our decoding function is P equals 9 times C mods 26. So I'm assuming P is the... What does P stand for? So yeah, the encrypt function is C equals 3 times P. What's P for? We have to solve for P. So I'm assuming P is the plain text. Gotcha. Let me look at this. So P or our plain text. Well, no, if you're encrypting it, that's not the plain text. What's that? Okay, whatever. So they do a 3 times P. 3 is the index, and then... Okay, I'm not going to try to make sense out of this. This is our decoding function right here. 9. I'm wondering what 9 is. Oh, is that a different decoding equation. Okay, wait. Oh, it's literally the letter P. Maybe I should actually just read it instead of skimming. You should have realized. All right, let's zoom in on this joint. You should have realized that the code means to undo the. Yeah, we know. For instance, we encoded A equals 3. Then the encryption function was. Oh, so they already encoded something. Oh, 4 out of 5. I'm very tempted just to go on like GitHub. Be like, is there a multiplicative Python decoder and encryptor and brute forcer? That's dynamic enough for one-liners? Oh, there's a back. Okay. Don't get me wrong, this is helpful, but the colors are kind of throwing me off. Like, I thought this was like a HTTP website when I first opened it. Java program. Yeah. Oh, you gotta get up in 6 hours? Oh, that sucks, dude. Don't let me keep you up if you gotta, go to sleep and stuff. The keys that are not bad are called good keys. I should probably just start this from the beginning. Let's go to episode tutorial 1. Cipher challenge. All right, you have just learned the Caesar cipher. I already know this. Instead of adding a constant number to each blah blah blah, blah blah blah, blah blah blah. So verify below how A B C D E F G, like the alphabet, is encrypted. How does multiplication ciphers blah blah blah? Oh, these are just ciphers. Okay, I just need like documentation on how it works. Is that too hard to ask for? I just realized I never dropped the link to the article in case if you guys wanted to actually read it instead of having to go to my website. Here, I got you guys. Ooh. All right, sweet. Share post. Let's copy that link. Sweet, there you go. So I'm really sorry I could not attend the stream, but I'm about to go to sleep. We have to ride for a 2-hour random community party. All right, man. Glad you can make it for the time you did. We will see you on Discord and other places. Okay, so they're using a key of 5, obviously. I think. Yeah, okay, cool. A equals 5. So knowing that the key, A equals 5. Oh, so is A... I'm too lazy to read this. It like hurts my eyes a little bit. I feel bad for you guys too. You guys are gonna have to like stare at me looking at this website. Have a good evening and happy coding. For sure, man. For sure. All right. We need to figure out. All right, so we have the encryption done. I think we should start coding the encryption. We already know how that works. We can worry about the decryption later. And I'm going to use the reverse cipher as my new reference now because it's like the shortest code we have. So let's start and make a new folder or file. We'll call this I am fine staring. Mati, come on now. Oh, that's funny. You made me lose track of what I was trying to do. Oh, multiplicative, right? Multiplicative cipher. Hopefully I spelled that right. Multiplicative cipher. Sweet. So we're just going to copy all of this. Drop that in here. We can get that banner in here. So banner is equal to, all right, and then sweet. All right, so this will be multiplicative cipher. Oh, that's long. Look how long that is. I'll just do, because I don't know how big terminals are going to be. And I don't want like all this all heap flashed. You know I did. I'm playing for the record. I'm playing. I might just do like, I don't want it to be too long because if they're on like a terminal screen and it's just like spanning, because this by itself, reverse cipher, that's like my whole window. And if I were to like, yeah, see, it's already kind of like weird if you have your terminal like this. So, all right, we're gonna have to figure something out. So we don't need Python anymore. What we do need is to copy this. So this right here is the, I guess, structure. We'll worry about the banner later. It's not the most important thing. Oh, we should probably incorporate this into our CLI. So we can do a multiplicative cipher. Then we can do the reverse cipher. Sweet. So let's do an elif ciphering option is equal to tech_m, which is the multiplication. Then we do an os.system. Then we do an f python 3.ciphers /reverse /multiplicative. Always say it like that so I make sure I'm spelling it right. And then our string arguments. All right. Why are you giving me an error? Oh, it's not system python 3 dot slash. Oh, I forgot to close the curly brace. Gotcha. All right. what time is it? It's 1:14. All right, so we're about like an hour into this. Cool. So we got that implemented. Now, if I were to run it, this would run, but we still need to incorporate the actual, I guess, stuff into it. Let's go back to our tag. We'll just copy. Am I like overthinking this, guys? Are you guys like Chris? Just like type it in. I'll just do multi-cipher right now. Oh, whoops. I can't copy that. I need to copy this. And then we can go to here. So it's in the banner, Control H, Control Alt, Enter. And then if we were to print our banner, let's do, all right, so if we were to do a Python 3 main.py, then do attack M for the multiplicative cipher, it just prints out the multi-cipher. All right, there you go. So in our main.py, we can go ahead and actually just do, oh, we should do this in like alphabetical order, shouldn't we? All right, so attack M, multiplicative cipher. All right, sweet. And now we can add that space here. So Caesar cipher, then we got to have, so it's CMRV. All right, so we can cut this. Right, hit enter here, enter here. All right, there you go. So Caesar cipher, reverse, visionaire, and then we'll have to implement the multiplicative. Sweet. So let's go down here and get our help menu for ciphering options. Then we can do our help as for menu is equal to our doc string that I'm not going to write for a little bit. All right. Now we can do our parser and CLI. I literally just need to copy this entire thing. Oh, wait a second. In a reverse, did I ever even change this? Yeah, no, I didn't. So in a reverse cipher, this needs to be a, oh yeah, this is Caesar main. So this needs to be reverse main. And this needs to be reverse main. Awesome. So now we have the multiplicative. All right, so this is kind of a bad reference now that I think about it because we need to account for our ciphering options, right? So we can go to our Caesar cipher. Oh, excuse me. I'm kind of hungry because I haven't eaten yet. Let me just eat this granola bar as we're working on this. Okay. So we need to figure out what our actual options are for arguments, right? I think what I'm going to end up doing, because this is so similar to the Caesar cipher, I'm literally just going to copy this instead, because there's a lot more less work we have to do. All right, so from right here, boom. So this is going to be multiplicative cipher, or what? Not cipher. Main, and then this is going to be multiplicative. Oh, not cipher. I keep doing that. Oh my gosh. Main. There you go. So now we're actually running the cipher as it is, like the main code. Cool. So let's start from the top and just make our way down. So Caesar parser is going to be multiplicative. I think I might just copy this word. All right. We need to have a key. We need to have this I. Did we never change this? I'm so dumb, everybody. This tag F needs to be an I. Then we have to have our tag T. And then our tag O and our R. Okay, cool. Ramses, be quiet. It's my dog. I don't think you guys can even hear him, but so instead of multiplicative cipher, we are going to have to do, or instead of Caesar cipher, we're going to have to do multiplicative cipher or parser, and then we have our encrypt Caesar. So we'll need to have our encrypt multiplicative there you go. And then we'll have our decrypts. Cool. So this actually, for the most part, seems just about accurate on how we're going to want to have this program work. Cool. So let's go like right here. We'll just say parses arguments for ciphering process. All right, then we can say encrypts multiplicative cipher. All right, sweet. Let's say def this. Then we'll have our plain content. We'll have our key, and then we'll have our print CNT. All right. So I think that's all the stuff we're going to need. Let's do a pass. All right, so we go down here. No key argument specified, blah, blah, blah. Oh, yeah, we're also going to need a brute force, so. Cool. So, I guess we should get started on the encryption process. Is that what I need in the actual functions? Inputted content, key, print content. Okay. Yeah, that's right. So now we're going to basically, all right, so that algorithm works on, how do I want to do this? Are we going to have to use Unicode like our last one we did, or the Caesar cipher? Okay. So I don't want to read this website because I don't feel like it. But all right, yeah, I'm kind of lost. I can't even lie. For our Caesar cipher, right? We accounted for Unicode indexes. So what we could do is basically copy what we did for our Caesar cipher, but change the algorithm so that way it will run the algorithm specific for the multiplicative cipher, which is this, and we just incorporate it into this with us accounting for that Unicode index. We're going to try it. That's what we're going to do. So let's drop this in here. Awesome. So the first thing we're going to need to do is change encryption key to key. Actually, we should probably make this encryption key because it's more specific. People will know what we're talking about. Cool. One problem that we may have, I'm not sure. Let me see. Okay. I guess we can check out the article I wrote. Yeah. So for indexing, A is 1 for Caesar cipher, right? Well, I guess it doesn't matter too much because it's more of, I'm going to check out like Caesar cipher. When they're explaining it, they're just referring to positions rather than index. Yeah. So if I were to do like, yeah, so A has that index is 0. Should I give it like, well, that's the thing. We're not giving them Unicode, or we're not giving them English indexes. We're giving them Unicode indexes if we're doing that. So we need to account for character positioning, because if we use Unicode, we're not, because by using Unicode, we're not accounting for their index positions, standard index positions. Instead, we're accounting for their positions in that alphabetical order. What we would need to do is find a way we actually, so we'll probably need this variable here as well. Sweet. All right. So if we were to do something like this, because right now this is just a Caesar cipher, right? We need to take this and incorporate it. So the index, I guess we could, dang. So how do we get their index? We could convert the letter to a lowercase and match it to a dictionary. I feel like there's a more efficient way to do this. All right, I'm going to check out how other people do. I don't want to just take the code, but I want to see. I'll do like an exclamation point GH multiplicative cipher Python. And then I'll just do a multiplicative cipher Python. So we'll pin this tab. Sorry, that's going to go. We can keep that there for now. So enter the message. This is a very secure message. So what's the 11 and the 19? I know one of those are probably the key. Yeah, okay. I don't get that. Oh my gosh, I'm so sorry. I didn't play any music. I might play some music if you guys want, but... Hello? Let me put it over here. Glad to play that royalty-free music. You know how it is. How high up is my volume? All right. I have no idea how loud or quiet that is for you guys, so hopefully that's good. If it's annoying, I'll turn it off. Just let me know. All right, let's look at this. So J equals K equals 0, okay. Oh, that's like the inverse part of it. I just need like... So multiplicative cipher in Python. All right, is the music worth it, people? Because the song's kind of annoying. Get the most for your locksmith service. All right, music's going off. Sorry, people, it's annoying. But hey, if you guys want music, let me know. I'll turn it back on. But for right now, I'm just leaving it off. Modern cipher solver. Well, it's kind of what I'm doing, but I'm gonna have more than just ciphers. Does she have the multiplicative? So if CC is equal to M, print multiplicative cipher, menu E for encryption, choice. while true, choice equals input, please enter your choice. Encrypt, decrypt, brute force, or X for exit. Okay. And then they say, welcome to encryption, welcome to decryption. And then they say choice 2, not appropriate choice. Then they say, oh my gosh. So is there like a multiplicative section I can just go to? It's weirdly dynamic. So that's not what I'm looking for. What? C++ implementation, no. Alright, this shouldn't be too difficult, I would think. Okay, so the affine, yeah, I've heard of affine. Is it just like a combination of the two, right? Or like a, I guess, weird mashing of the two? So C is ciphertext, P is plaintext, N is 26. Oh, A times this plus B. So what's the B here? Are the two keys. So we'll have to incorporate the affine sometime. But I'm trying to do just the general multiplicative right now. All right, let's see if we can actually get actual progress done with this. So we need the index of the letter, right? What I'm saying is, I guess we could just make a dictionary of the letters, you know, A through Z, and then the index 0 through what, 25? All right, and then we can say, we can check the character, then we can check to see the value of that character and match it, or take that value of the character and use that value of the character as the index. All right, then they have the key which they inputted here, and then modulus 26 it. So they'll say for each character in the plain context, then they'll match it to, okay, sweet. So that's what we'll do. So we'll just say indexes. I'll say index dict. So index dictionary is equal to a dictionary. And in this dictionary, we're going to have, all right, A, and then what, it's a colon, and then 0, right? All right, yeah, that's going to take too long, so we're just going to try to... Can we do this in Python? I feel like I've done this before. So we can say A is equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. All right, awesome. And then we're just going to do a for I in alphabet, or for I in A. We can just do a print, and then we'll F string. Oh, we'll just cancel that. We'll just say C is equal to 0. All right, then we'll do a for I in A. Then we'll do a print, an F string of our letter, which would be I, then a colon, then our number, which would be C, right? And then, oh yeah. So for I and A, oh yeah, so we had to do a backslash. So backslash, oh, we can use double quotes on the outside. All right, sweet. And then we can just do C plus equals 1. All right, there you go. Because I was not trying to write all that out. And we can delete this. Oh, I forgot commas. So for I and A, we'll just add a comma at the end. There you go. The comma one. Oh, whoops. For I and A. Oh my gosh. The havoc. There you go. This, and then the C plus equals 1. There you go. Perfect. All right. I could have even done the backslash T at that point, but it's whatever. Oh my gosh. All right, there you go. Why is it like, oh my gosh, guys. C got reset, so we're redoing it. There you go. Oh my gosh. There you go. All right, perfect. So our index dictionary is this. So sweet. Our index is going to be, so for each character in that alphabet, right? We're going to do a 4 letter index in our index dictionary. Welcome back, welcome back. Dots items, I think that's the function for it. Then we will we'll say if our letter is equal to our character, then we can start the encryption process. Then we can just break, right? So if the letter is equal to the character, we'll break the loop and then it will go back up. So then all we had to do is modify this to work. All right, so we can just say output plus equals. So our output will be our index. Then we can add our, multiply? Our encryption key. Wait, how did we have this before? So if character is upper. Oh yeah, so because we're using Unicode, we're accounting for that. So instead, we're going to have to use a method. So if the character is upper, all right. Oh my gosh, guys. So let's just redistribute this, right? So we'll have output plus equal our index multiplied by our encryption key. And then we are going to, what are we going to do from here? So output plus equals index multiply encryption key. And then we are going to modulus 26, right? So modulus 26. So this is going to give us what? Our new index. Yeah. So now we have to go back through this and match our index to the character. We could make some functions, right? We could get a function that would get index, right? And then get character. So that way we're not making this process too long. So def get index. And then this would just be the character. All right, and then we're going to have our def get letter, I guess. And then this one of our index. So instead of character, we'll do letter because we're not accounting for characters. And then we'll have to do what we're doing here. So we'll take this index dict. So we'll basically, we're basically just going to do this, right? So for letter index items, guys, this is blowing me. So we're doing for letter index in, so for L, I, in our index dictionary items, okay, then we're going to see if our letter is equal to L, then we can return the index. And then here, we're going to say get index. So for if index is equal to I, we'll return the letter. Please use nerve. Matzi. You clearly haven't met Python. Hey, Cosmodium CS, which hypervisor do you recommend, VMware or VirtualBox? Honestly, it doesn't matter. I use VMware. It's just because it's what I was told to use. But they're both really good. I know a lot of people use VirtualBox. I think VirtualBox is a little bit more popular. It might be, but I know if you have the pro version of VMware, it's a lot better. So it honestly doesn't matter, but what I use is VMware. And I like your username, Tech with Turbinator. That's cool. Gets index from and then here we're going to do the opposite. So gets letter from index. I always say form instead of from. From index. Sweet. So here, hopefully, in this code, we can save ourselves some lines with these functions. So we're saying if our letter, so here we'll say letter is equal to get letter character. Perfect. No, we need to get the index, right? Hold up. I'm hurting my brain. What's the formula? Where did the formula go? Oh, it's right here. All right. This needs to come down over here because I need to figure out what I'm doing. So this is what we're implementing, right? This right here. We need to get this into here. Right here, we're getting the index. Well, we're solving for the index. Then we're just going to plug it into the get letter. So letter equals get letter character. So get letter, we're taking in an index to get the letter. Oh, I see what I did. Delete this. I see what I did. So move this. There you go. So we're getting our letter. Why do we need to get the letter again? I forgot. Oh, I think this is for decryption. So there you go. For character in the plain text, if it is a symbol, we're going to skip it. If it's an uppercase letter, then we are going to get the index. That's what we need to do. We need to get the index. So we will say index is equal to get index of the character. So then we can plug it in here for our index, then get that new index. Then we will have output plus equal when we plugging it in. Oh, I see what I need to do. So there needs to be two different ones for each option. So this needs to be a lowercase. So we need to do a dot lower, right? So character dot lower. And then when we output it, we need to have our say cipher character is equal to our get letter from our new index, and then we can output plus equals our cipher character okay. Output plus equals cipher character, and we need to make it dot upper because we made it a lowercase for the equation. So all of this should encrypt it and give us the letter and add it to our output. Fingers crossed. So now we just have to do this all over again. but for lowercase letters. So I don't think we need to break it anymore, because we're not. Oh, so if yeah, it will return, so we don't need to break it. Okay, what are we doing now? So here, our index is going to equal get index. We don't need to lowercase it because it's already lowercase. And then we can not have to uppercase it because it's already lowercase. And all right, in theory, this should work if our code is configured correctly. Technically, the only one that should work is the encrypt. So we can try it. I doubt it's going to work heavily. But so if we do attack, attack M for the multiplicative, then attack E to encrypt, attack T of text, and we'll say hello, and then attack K, we'll say 7. No way! XC77U. Is that correct? So wait, our H should be X, our E should be C. Okay, no, it does work if we're using the encryption key of 7. Guys, that works. Look at that. Look at that. We got the encryption process done. It's just math. It's just math. That's all it is. No, decrypt it. That's what I was saying. I need to figure out how I can decrypt it. Oh, now decrypt it. Yeah. All right. So, no, you're right. You're right, Matze. I need to figure out how we can decrypt this thing. So, we have the encryption process. So it should just be the inverted version of what we're doing here, right? The only problem is this little ciphering equation. Because even the brute forcing is just the decrypting process. We're just decrypting it X amount of times. Okay, so I guess we can kind of just find the decryption. I wonder if we can find multiplicative cipher decryption. Okay, is there like an equation? That really weird looking website was kind of talking about a little bit. All right. So PK mod 26. Oh, to the power of -1? Is that what it is? Wait, okay, hold up. So C equals P times K to the power of -1. Quickly, before we start implementing that, if I make hello a capital letter, will that still work? Yeah, it's a capital X. All right, cool. So that's pretty cool. Just making sure that works. So it says that if we make it to the power of -1, it will work. So K's are key, right? So if we copy this, oh no, we need to take this whole thing, copy it. Oh, I can't wait to do that notation. Oh my gosh. All right, now we're just going to paste this in here. So this is going to be the Decrypt multiplicative cipher. Then we can just say decrypted content. And then the only difference is that this needs to be to the power of -1. I think the minus is throwing it off, so there you go. The power of -1 like that. And our encryption key to the power of -1. All right, so if we take this and then instead of hello, we do XCZZU, then we're going to have to change the attack E to attack D. No argument was specified. What did I mess up? It's probably like the attack D. I don't know if that's implemented. Attack D does this. So decrypt multiplicative. Okay, so this should be fine. So decrypt multiplicative cipher. It throws these three things into there. Then it goes through here. This should be working, right? This should be working. All right, let me see. So our new index equals our index multiply. Oh, wait, that might not have to be with the, well, with this, we need to invert it, right? Because for character in symbols, we're getting, no. So let's say this is X, right? So for character in plain text, that would be X. Then if character is in symbols, we'll add it. We'll say, so it's a lowercase character. So let's say get the index of that character, which would be, all right, so our X. Oh, so the plain text is 23, but the ciphertext of X. Oh no, that's still 23. Okay, never mind. So it would take 23, and then it will multiply it by our encryption key, which is 7. Wait, let me do this on my calculator to see if this equation actually is going to work. There you go. So if we have 23, and then, oh, we'll multiply it after, right? Because we need to take our encryption key of 7 and what's something to the power of -1? Oh my gosh. I don't know. So if you do something to the power of -1, what does that do? 7 to the power of -1. Okay, so it's 1/7 in fraction form. So instead of this, could we just do 1/key times the index modulus 26? Is that even going to work? What? So can we do 1 divided by 7 times 7? I'm doing something wrong. That equals 1. Oh my gosh, guys. Oh, let me do this through Python. I'm so dumb. Okay, you can literally, we can do this on Python. We'll do Python 3. All right, so if we take our index, which is 23, and then we're going to multiply it by our encryption key, which is 7, and then take this 7 to the power of -1, and then modulus 26. That's 3.2. Our H is... No, I see you have the 7 to the power. It's giving me an error if I take away the parentheses, I think. Or maybe I'm just being dumb. Bro, you always tell me Python is the key to all things. It is, it is. Let me try this. No key or argument was specified. Let's get rid of this. So we don't need the Caesar cipher anymore. We can close this. So, multiplicative cipher. How are we going to figure this out? I'm trying to figure out, like, it says that the equation is CP times k to -1. Let me see. So, oh, this is... All right, this would be the decryption. And this would be decrypts. All right, so we have our index times our encryption key to the power of -1. If we run this, just to see, all right, no key or argument was specified. So let's go to where it says no key or argument was specified. So it's checking to see if there's a type error. Oh, is it like a string or something? All right, we're going to comment this out. We're going to comment out this try, and we are going to shift this whole thing back. All right, so let's run this. And what error are we getting? Type error, you can only concatenate strings, not typed strings. Output plus equals cipher character. Cipher plus equal, well, output plus equals cipher character. So we're getting the index with this. Then we're just getting the letter that matches that index. Unless if our index is in a string, or is an integer, int new index maybe. I mean, isn't an integer, my bad. Okay. Int this. So it seems like it just encrypted it again. That's not right. So if I do the hello thing, I get XCZZU. That's right. So what if we encrypt it with XCZZU? Is it going to give us that weird dad thing? No, it's not. So it's doing something wrong. I don't think this... Is this the right equation, maybe? Like, is there a different, like... (26 times 12). No, this is the same thing again. equals C times K. Wait, what's the M? What? Just give me the bruh. Look how freaking blurry this is. I just need the equation. No, now they're doing the inverse, or they're doing affine or whatever. Plain text multiple. Yeah, this is the affine. I just need the equation for multiplicative. Nothing else, nothing more. 5L. Yeah, now the encryption works. I need the... Alright, so it seems like from this post and this post, I think that this is actually the right equation. I might just be doing something wrong. So let's figure out what on earth I'm doing wrong. So we have our ciphertext is going to be equal to our P times K. Maybe, wait, if our key is like 7, right? Now, if you do something to the power -1, I think you just put it 1 over that value, right? I'm going to just ask Siri again. Hold up. 7 to the power of -1. Yeah, so it's 1 over that value. So it's going to be 1 over 7. So can we do 1 divided by 7? Instead of... Can we do that? So we'll just do 1 divided by the encryption key. And then in here we'll do 1 divided by the encryption key. And then we can get rid of this -1. And if we try this, maybe. So tag D, this. Why are we getting this dad DC? What's wrong with this? Is it one of these things? Or is it like... So for letter I in our dictionary, if our index is equal to the index, if our inputted index is equal to the index that matches the letter, it'll return the letter. That's fine. Alright guys, we need to figure this out. How are we getting that D? How are we, okay, how are we getting it though? C equals P times K. So 1 over our encryption key multiplied by our index modulus 26. I'm just going to keep running it because, you know. So how can we, from X to, so X's value is what, 23, right? So X's value is 23. And how we go from the letter D, which is 3. So 23, there's no... Yeah, Matzi, as soon as I said it, I heard it. I was like, okay. This is why I don't stream. This is why I do stream, but this is why streaming is not always the best idea. Because at least I can, like, retake it or something if I was recording. So C equals P multiplied by K to the power of -1 modulus 26. So we'll say index times our encryption key to the power of -1. So instead of this, we'll go down here to the power of -1. Why are we getting this? Are we doing something wrong? I just looked up as you said it. I'm sorry, Mati, that my streams aren't impeccable enough for you. All right, so we get our index, right? We're getting our index from the character. Well, I guess we don't need to focus on this one right now because there's no uppercase characters, it's whatever. And then we'll just copy whatever we fix in here up to here, right? So if we get our index, right, get an index character, let's print out our index. Print our index. All right, cool. Then our new index is this. So let's print our new index. I feel like the print statement is the #1 debugging tool. I don't care what you say. And then our cipher. So can we do print cipher? All right, cool. So if we try this, so we got okay. So it's printing our 23, which is our index. Then it's going to get our new index. Then we make our int. Oh, okay. So it needs to be. Do you have to round? Oh, doesn't it always round down or something? Is that what's going on here, or is that like? So it's because we're working with doubles. I mean, yeah, or floats. So 23. All right, guys. Decrypt equation. Not the monoalphabetic. All right, well, that's basically the same thing, but it's still no decryption. All right, come on. Calculate equals. Not substitution, just trying to do the normal basic multiplicative cipher. AX plus B. Not the affine, just multiplicative, not affine, not anything else. Oh my gosh. Yeah, decryption. This is the exact same photo. Oh my gosh. So we have whatever this is. This is the encryption process. This is the decryption process. So we have our P times K to the power of -1 modulus 26. So this should be basically the exact same thing as this, but we're just getting these. Okay, wait. So our index, right? We're getting 23, and then they get 3.28 from our new index. So our new index is that 3.28. So the letter that should be there is what? Zeros A, then it's B, C, D. Yeah. So I guess it's rounding up to 4. So in here, we'll just do a int index. Let's see this. All right, it's kind of hard to... Sweet. So there's 4 values, right? The first one is our index, which is 23. Then our new index is 23. Oh, no, I did the int version of the index. Hold up. That's what I meant to do. I meant to do Alt Shift down, int of our new index. There you go. So we have our 23. Then the int version of this is 3. The int version of this is 0. A 0.5. So do you have to round like to the nearest tenth? Oh, okay. So we'll have to find a way to round it accurately. This is annoying, dude. So now it's getting like DADDC instead of HELLL. This is so confusing. Like, why is this? Like, it should just be math, right? You just plug it in and it works. Because that's how math works. Our index and our encryption key multiplied by -1. Wow. All right. We are reaching the, I guess, quote unquote time limit I have for these streams. So I think I'm going to end it here. We have the encryption working. So next stream we'll work on the decryption. And if we figure that out, then we can just do the brute forcing. And we'll be done with multiplicative. So yeah, that's going to be it for this stream. Let me go on my face. So yeah, hopefully you guys enjoy the stream. Hopefully it was something a little bit more enjoyable. I know the other streams I've done before or previous have been really laggy, but hey, it seems like YouTube's fixed the stuff, or maybe I did something to fix it. Who knows? But yeah, make sure to leave a like, subscribe, and leave a comment, share the video, and all those types of YouTube algorithm things. And I'll see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.